This is the fourth nuclear physics video, and I'm going to talk a little bit about the Standard Model. We don't need to know a great deal about it, but it's interesting. You know, it's physics. What is everything made of? What are the fundamental particles? What is everything? What are the little bits of Lego that the universe is made of? And this is the Standard Model. So everything is made of fermions and bosons. I remember fermions are firm. They are actual, what we think of as being particles. Bosons, I'll talk about in a minute. They're kind of wave particle, messenger carrier things, right? But I imagine as fermions as being firm. Two types of fermions. There's hadrons and there's leptons. I talked about hadrons in my last video, baryons and mesons. They're made of quarks. The 6 types of quark: up, down, top, bottom, charmed, strange. We only need to know protons and neutrons. Hadrons are heavy, leptons are light. They are light particles. We're very familiar with a lepton. It's called an electron. But there are electrons and tauons and muons. And there's also neutrinos as well. And each of those 3, electron, tauon, muon, has its own neutrino. So there are electron neutrinos and tauon neutrinos, etc. And then all of these particles have an antiparticle. So there's anti-up, anti-down, anti-electrons, which are called positrons, anti-neutrinos. All of those fermions have an antiparticle. Let's talk a bit about bosons. What are bosons? You need to know very little about them, but they are force carriers. They carry forces, the fundamental forces, you know, particles attracting and repelling each other. In quantum mechanics, we imagine them as being carried by bosons. They exist for a very short time. They are virtual particles. They pop into existence out of nowhere. They carry a message and then they disappear. Okay, they are virtual photons, not the photons that we're used to coming from a light bulb. These are very weird photons. They appear and disappear. And the photons from a positive charge, I'm just going to get my little video working again. There you go. Took ages to do. The photons from a positive charge, their message is, if you're positive, go away. If you're negative, come here. That's the message that they carry. And the more bosons arrive, the stronger the message. Okay. Electromagnetic forces, the force carrier is photons. For the strong nuclear force, the force carriers are gluons. For the weak nuclear force, which we don't need to know anything about, it's W and Z bosons. A recently discovered one is called the Higgs boson, which gives other particles mass, apparently. And then there's a theoretical one called the graviton. It is possible that gravity is carried by bosons as well, but they've not been discovered. Very theoretical.